Hello, my name is Attila Uderski. Welcome to the PLANHEAT Training Module 3 Planning and Simulation Module presentation. Today, I would like to give you an overview of the Planning Module 3, which has been going on since the last few weeks and months within the PLANHEAT project. I would like to first explain the planning module's relation between mapping and the planning module, to provide some general information about planning and the simulation modules, both on city and district approach. We'll focus on district planning and simulation modules. And lastly, to let you know about the status of city planning and the simulation module approaches. So for those who are attending this webinar for the first time, let me show you the project in one single slide. So as you can see, the PLANHEAT platform deals with different demands and supply sources, and based on those, it plans a new scenario on the use of waste heat and renewable energy sources. By having those results, it will enable the simulation of new scenarios and KPIs evaluation. Again, a reminder, we are working together with 3 cities from different geographical locations. So first one is Antwerp, which is representing a northern city, then Lecce and Velika Gorica in other locations. Both of these cities have their own certain characteristics. And let me introduce also the consortium behind PLANHEAT. It's an international team of different experts. So about the PLANHEAT main structure, on this slide, you can see the different steps for achieving that. Here, in the planning to implementation process, PLANHEAT can contribute in a different way. As in the upper part, you can see the national or regional government, which is usually in charge of some kind of financial policy instrument, such as renovation subsidies, but can be also in charge of subsidies that are connecting to a heating grid. The local authorities can often go further than only a policy instrument, as they aim to facilitate the process from a project idea towards full implementation. So what is the PLANHEAT project is suitable for? On the first place, it's suitable for putting together strategic action plans for cities and regions. It can also visualize energy demand and consumption, while it also can plan and simulate heating strategies, including a district heating or cooling route optimizer. Actually, this should be quite suitable for replacing a first high-level feasibility study. So why we are addressing heating and cooling planning in a city? As probably you are aware, the Article 14th of the latest Energy Efficiency Directive, member states had to report the potential of district heating and cogeneration with a techno-economic analysis in the territory. The results were quite inconsistent. But the main conclusion is that a lot of questions arise at national level on which heating or cooling technologies to pursue for decarbonization of the demand. So in order to understand how to achieve those sustainable energy action plan targets at each country, we should also understand how the use of financing instruments or structural funds, in some cases, to achieve those objectives. The city heating and cooling planning will help to propose to ESCOs precise plans so that municipalities or cities can apply for additional funds with the concrete plans and interventions for heating and cooling. It's also suitable, of course, to connect local and national heating and cooling plans. So as you can see, there are many more goals when we are talking about CEAP goals, because renewable energies are not the only one for that purpose. So it can be also geothermal, biomass, and any other sources that we can use in our case. So how is it possible then to plan low carbon heating and cooling? So first of all, we should be concentrating on one single main target. We should decide what are our main objectives that is probably coming from the action plans. It can be also very possible that it will be our key performance indicator. But if you are not really aware of that, the PLANHEAT tool can also help you with that planning criteria. So as you can probably aware, many drivers will need to be taken into account, like environmental, economical, local, renewable energy source potential, and any other policy or regulation driven issues. But we should keep in mind it always key performance indicators driven. So the planner in PLANHEAT have to have a clear vision of that. So let's provide you some general information about the PLANHEAT planning and simulation modules. So the most important things to say here is that it is a high-level decision support tool for defining and assessing sustainable heating and cooling future scenarios for different sectors in residential and tertiary levels. It has quite a flexible approach that is adaptable for different user needs in terms of data availability and scope. As you are aware, data is not always available, but PLANHEAT can be quite adaptable within that term. It also has a measurable approach because impacts, benefits, and savings quantified by the key performance indicators in the energy, environmental, economic, and social terms. So it is distinguished by two different modules. The first one is the city planning and simulation module, which has a timely resolution of year, and it's concentrating its resolution on a spatial level for a city. While the other one is the district planning and simulation modules, which are hourly and annually resoluted in a temporal way, and it has a spatial resolution for buildings. So what kind of planning and simulation workflow needs to be done here? So as it was already mentioned, it needs to be identified by the planner, the key drivers, and the main objective. So the baseline scenario is characterized and assessed with reference to different key performance indicators computation. Then the planner can select the planning criteria in target of KPIs input by the planner. Then the future scenario is characterized and assessed, again, in reference with the key performance indicators computation, while in the end, feedback is given by the check and comparison stage. So first of all, if we would like to characterize the baseline and future scenarios, we have to decide as a planner where we would like to act, whether we would like to characterize the energy systems or the energy sources between conventional energy sources, renewable energy sources, or any other unconventional energy sources. So, characterization of energy sources for baseline and future scenarios, they all required for all energy sources for primary energy factors and emission factors. This information actually could be an input by the users themselves, but if this information is not available, then the PLANHEAT database contains the default values for the whole EU 28 region. So, about heating and domestic hot water production, we have different technologies available in the system. So starting with the very conventional and usually used boilers like a gas condensing boiler or non-condensing boiler, oil condensing and non-condensing boilers, or biomass boilers, followed with electrical heaters. Then combined and heater power is also taken into consideration with many subgenres. Solar thermal technologies with flat plate collector or evacuated tube collector, thermal storage for daily, hourly, or seasonal terms, heat exchangers, different compression heat pumps, deep or shallow geothermal, air compression heat pump, waste heat compression heat pump, or water compression heat pump. The system is also able to browse with absorption heat pumps, deep geothermal, shallow geothermal, air, waste heat, water, or for conventional fossil sources. So let's see how cooling production can be characterized for different technologies. So the main two big groups like compression chillers, again deep geothermal or shallow geothermal, air compression chiller, excess cooling compression chiller, or water compression chiller, while absorption chillers are categorized for deep, shallow, air, excess cooling, or conventional fossil sources. So if we would like to provide parameters for heating and cooling technologies characterization, we need to provide capacity in kilowatt, efficiency, technical minimum, ramp up or down in minutes, and fixed and different variable and fuel costs, euro per kilowatt or euro per kilowatt hour. Actually, this is the information that can be also provided by the users themselves, or as it was mentioned, can be used from the PLANHEAT default database. So in the next slide, we can see a typical technology database template sheet for default values. And here, the thermal storage technology is deeply discussed. So it's actually a condensing boiler, which has a subcategory for natural gas, and the different energy technical financial data can be browsed by the user. So let's see what is the relation between the mapping and the planning module. On this slide, we can see the inputs and the relation between the mapping and planning module. After the mapping module, the planning or the simulation modules can be started. The planning module has different steps. The first one is to select the planning criteria itself. In this step, the user selects out a list of a planning criteria which are the most important to the user. For example, a cost-effective heating supply, a large amount of greenhouse gas saving or reducing the non-GHG emissions. The second step is the scenario development, where the user constructs a future scenario either by using a key performance indicator panel, either by providing a more detailed input. So here, the different criteria for economic, environmental, energy planning, and social planning can be seen. Actually, the users can select out of this criteria. So going on with the planning criteria and key performance indicators, the third step is in the calculation, where an hourly simulation and operational cost optimization can be performed in the simulation module. This theoretical or technical supply potential will be an input for the planning module, serving as a constraint in the scenario development. In addition, there is also a calculation step between the user selecting the planning criteria and developing the scenario. For instance, if the user selects a scenario where the only concern is cheap heat, one could only end up with fossil fuels like gas or coal. But when the user values greenhouse gas reduction as well, like excess heat, biomass, or solar thermal, it will be important. However, when one selects a reduction in the non-GHG emissions, the calculation will not recommend biomass. It can actually also a viable situation. For instance, natural gas boilers can be very cost-effective. However, they will score quite poorly with respect to achieving a higher penetration of renewable energy or a reduction in greenhouse gas emissions. For that, the user may prioritize greenhouse gas reduction, while still to a lesser extent take into account the cost of the solution and, for example, noise reduction. So in this slide, we can see an assessment of the baseline and future scenarios with energy balance, demand, supply, the computation of key performance indicators, and finally, on the right side of the table, a check and feedback, and actually a comparison through the key performance indicator panel. So let's see how district planning is done within PLANHEAT. In this flow chart or workflow chart, the different steps are defined when the district planning module is taken into consideration. So first of all, the user can import and visualize any relevant information from the mapping module. Then, the user can build up baseline scenario characterization according to residential, tertiary, or even the transport sector. And the baseline scenario on an hourly basis can be assessed. KPIs are computed in the meantime for the baseline scenario, and the planning criteria and the KPIs are selected. On the fifth step, energy sources can be prioritized by the user, and the future scenarios are characterized. That will lead to the optimization of the district heating and cooling networks after all. So let's see what are the main features of the district planning module. It is, as it was mentioned, interfaced to the mapping module, district and supply mapping module as well. And it facilitates the management of information provided by the user about the baseline and future scenarios based on GIF-based shapefiles. It also has a submodule for electrical transport sector simulation. It can also be connected to the PLANHEAT database to provide default values in the case where information or data is not available. The district planning module also enables the users to run annual energy balances, matching hourly heating, cooling, or even domestic hot water demand with hourly operation of the heating and cooling technologies. It also, of course, enables the optimization of district heating and cooling networks. So in the next slide, the first prototype of this district planning module is shown. Actually, this is taken from an Italian version of the prototype, but you can get a glance how it will look like and how it will operate at the time it is going to run. So let's see what kind of operational buttons and modules do we have in the first prototype of the district planning module. So first one is the energy sources tab, which actually focuses on the different figures and parameters related to available local energy sources. The DHCN tab allows the characterization of heating and cooling technologies, representing the link to both the route optimizer and the simulation module. The next tab is the building tab, which allows the characterization of heating and cooling technologies supplying individual buildings. While the planning tab contains the list of all PLANHEAT planning criteria that could be selected by the users in the process of defining future scenarios. So in this slide, we can see the sources tab as an example. And here we have different kind of energy local sources like solar, waste heat from different sources, excess cooling again for different sources, shallow and deep geothermal, biomass, wastewater even, water sources, aerothermal, and any other unconventional and conventional energies. So the user is able to fill in those parameters themselves. So let's see how the buildings tab will look like here. So this is for the city of Antwerp, actually, that this sample was taken from. While in the next slide, we can see how we can select buildings that are connected to the DHC networks. I would like to emphasize that all this is still in a prototype mode. So the characterization of generation points for DHC networks can be also done from the DHCN tab. And here how the prototype looks like at this current stage. They also have the option to provide different sources of energy. And here is an example of condensing boiler, which has a natural gas source. We also should talk about the DHC route optimizer, which has an objective to provide an optimized district heating network pipe design by identifying new consumer buildings to connect and how these additional costs will have effect on the network development. The DHC route optimizer has several applications, but first I would like to say that first application allows the end user to automatically select the building to be connected in a pre-study phase, while the other application is to pass the list of buildings to be connected to the network in a case when the optimizer will select the optimal routes for future networks to connect all the buildings in the list. So here's how the first application looks like in the current development of the prototype. So the user has the option to select the district shapefile, then download the data from OpenStreetMap, and it can also exclude streets of the optimization if there are streets that are not fitting in the area. The user can also select the building shapefile, then load it, and also exclude buildings from the optimization if necessary. In the supply sources part, the user can enable the selection of generation points on the map and list all already located generation points within their capacity. Finally, the user can select the demand coverage objective in below. So let's say we are generating an example here, and this is how the first application will look like with automatic building selection. In the next slide, I would like to explain what happens if we plan to cover 50% of the district heating demand and therefore to select the corresponding objective in the interface of, for example, 29 megawatts. Check that the overall supply of 120 megawatts is higher than the demand coverage objective of 29 megawatts. We can therefore run the computation and obtain following results that can be seen on the picture. So let's talk about a few things about the second application, which is manual building selection. And in this case, one source has been selected to connect 380 buildings, which is actually over 1,624 buildings, for a total of 29 megawatts. The results panel summarizes the characteristics of the computed DHC network. So here, the district shapefile is also selected and downloaded from the OpenStreetMap as data. Then the building shapefile can be also selected and built into the optimizer. And the results will look like this with the manual building selection. Okay, going on with the district simulation module workflow. It has 4 steps. Simulation on hourly basis for future scenario assessment, KPI computation for the selected planning criteria, and the check of computed values against target values, so that the user can export the final results as a final report. Within this slide, I would like to talk a few issues about the status of the simulation module developed in PLANHEAT. So actually the tool has been developed and finalized by using the Julia open source language, and the tool will be integrated within QGIS. The integration will be carried out in the upcoming months in the framework of Work Package 3 and 4. However, it should be noted that although the simulation tool is up and running, but it's still not GUI friendly. Some more features of the simulation module, like the hourly simulation of the heating and cooling supply for thermal storage. It can also deal with district heating, district cooling, individual heating and cooling. The inputs can be taken from the PLANHEAT mapping module, supply sources potential, from the PLANHEAT planning module, which is defined by end users, and the PLANHEAT database based on technology parameters. End user has little or actually no interaction with the simulation module itself. However, they are able to overwrite any input data from the PLANHEAT database regarding, for example, technology efficiency or minimum, fuel cost, operation and maintenance cost. Also, the end users will be able to choose between simplified and complete modulation and simulation. So finally, some overview of the simulation module. On an hourly simulation rate, only district mapping module approach can be used as a starting point. It uses various input data, but the main thing and the good thing is the end user has just to click on the run button. The whole simulation is done by itself. In the next step, I would like to say a few words about the planning and simulation modules development. So these are expected to be started within this month, actually. And to release the second finalized prototype that can be already integrated with the other PLANHEAT modules are expected in August 2019. Okay, and the last section of today's webinars is the focus on city planning, which I already also prepared a flow by steps. So the city planning module is imported and visualized by relevant information also from the mapping module. It has a baseline scenario definition and simulation with the calculation and visualization of reference key performance indicators. Then the planning criteria and the KPIs can be selected for future scenario definition. And this few slides upcoming give you a high-level approach how the whole thing will look like regarding the city planning module. And to show you as a sneak peek some possibilities to calculate numbers for different action plans. And as you can see, there will be a parameter panel on the below where you can set the different values for different measures. And this will be hopefully more user-friendly. Okay, this module again will be realized very soon, and starting and testing of this module will start also in August 2019. So mainly that was about that. More information will be upcoming in the later stages of the development of the PLANHEAT tool. We are also developing a guidebook on the e-learning platform of PLANHEAT. The guidebook is also updated continuously. We are also very active on social media, and our website can be accessed. So if you have any questions or any issues that you would like to share with us, please contact us through any of these communication channels. So thank you for your attention, and see you next time in the Module 4 webinar of PLANHEAT.